Alright, in this video I'm going to look at solving a linear trigonometric equation. Linear just meaning there won't be any squares, cubes, any powers in the equation. So this is an example right here of a trigonometric equation, sine x equals 1. So what we mean when we say to solve an equation, find the values of x, which make this true. So there's two ways you can think about it. You could think about the graph of sine x, which for this particular equation is probably the easier of the two methods. So think about the graph of y equals sine x, and just do a really quick sketch. So sine x, we know, looks like this, right? That's pi, that's 2 pi. So what we're asking is, when does sine x equal 1? When does the y value equal 1? Well, 1 is the maximum value right here. So what's going to happen right here? And this would be at pi by 2, half of pi. So from the graph, we can see that x is equal to pi by 2. Now, sine x is a periodic function. There would actually be another value over here, which is going to happen at 5 pi by 2, or 2 pi after this. Right? So you can write 5 pi by 2, or just write plus 2 pi. But it would also happen again in the third period. How are you going to get, and there's infinitely many answers, right? Because it repeats forever. But all the answers are just going to come at multiples of 2 pi. So at 2 pi you'll get this one, at 4 pi you'll get the next one, at 6 pi. So if you want to write all of them, what you could do is just write 2 pi times n, where n is an integer. So if n was equal to 0, then you would have just pi by 2. If n was equal to 1, then you'd have pi by 2 plus 2 pi, so plus the 1 period, which gives you 5 pi by 2. If n was equal to 2, you would get 9 pi by 2, which would be the one in the third, and etc. So this sort of formula gives you all the solutions. As I said, there is another way to think about this. You could also think about this as an angle on the Cartesian plane. Remember that on the Cartesian plane, we define sine of theta as equal to y over r. Assume r is 1. If r equals 1, then sine theta equals just y. So we're told sine theta, or we can think of it as x, is equal to 1. So therefore, y equals 1 and r equals 1. And remembering that x squared plus y squared equals r squared. If you sub in r1, y1, that means x must be 0. So you have a point on the terminal arm, so xy is going to be 0, 1. So 0, 1 is a point right here. So this is the terminal arm, remembering that the terminal arm is rotated from the positive x-axis, which means the angle is a right angle, or pi by 2. So again, you would get x equals pi by 2. In this case, theta, it's a little confusing because x is a point here, and we were also using x as the variable for the angle. So the variable for the angle is pi by 2. But then also any point on the terminal arm, any coterminal angle, which would be plus multiples of 2 pi. Okay, so either way, you get the same thing. So another example, sort of straightforward example, using, sometimes you can use special triangles. So let's say it was something like 2 sine x let's go theta. 2 sine theta minus 1 equals 0. And here I'm going to specify a range. Theta must be on the interval from 0 to 2 pi. So again, two ways to think about this one. This one, what you're going to need to do first is isolate for sine. So add 1 to both sides, and then divide by 2. So we get sine theta equals 1 over 2, which is a special angle. So this one I would probably advise to think about as an angle on the Cartesian plane. You need to know sine theta of a half. That corresponds to the angle pi by 6. So this angle here would be pi by 6. So theta is pi by 6. However, you're going to get another answer because sine is by the cast rule, or your related acute rule. Sine is positive in the second quadrant as well. So you need to come up with the angle that has a related acute angle of pi by 6 in the second quadrant, which is 5 pi by 6, or pi minus pi by 6, which is 5 pi by 6. Okay, so you could also think about this as a graph of sine, but it's a little harder here to figure out this is theta, where the angle is. So the maximum value is 1. The y value of 1 half is there. So we're looking for this x value, or theta value, and this theta value, so right here and here, which turns out to be pi by 6 and 5 pi by 6, but you kind of have to think about the related acute angles in order to figure out where that would be on the graph anyways. So in this case, when it's a special angle, and it comes from a special triangle, a ratio comes from a special triangle, I usually suggest thinking about it as the angle on the Cartesian plane.